Really, there's no shortages of challenges for the energy industry. We're dealing with aging infrastructure, supply chain risks, regulatory and policy hurdles, rising demand driven by electrification. I mean, by 2030, Europe's energy demand is expected to rise by nearly 20%, and grid flexibility is going to need to double. This is putting unprecedented pressure on all of our existing infrastructure. And as renewable energy integration increases, Europe's grids are going to have to require 7 times more flexibility by 2050. So these are very alarming and jaw-dropping figures, of course, but ultimately the future of energy, as we know, is renewable. But the other thing that it is very highly unpredictable as well. And that unpredictability specifically is going to be our greatest challenge. And the first is AI, and that's because artificial intelligence, in my perspective, is really the brain behind modern grid flexibility. A great example of this is at National Grid in the UK, where they use AI to predict supply and demand, run multiple simulations using thousands of scenarios in real time. And these use cases are allowing operators to really take more of a proactive approach, adjust resources accordingly, balance loads, activate demand response programs when they're needed, and ensure that there's little disruption on the grid. The second part is really, while AI acts as the brain, IoT devices act as the eyes and ears of the grid. Globally, we have over 10 billion connected devices, and that number is growing exponentially. Things like smart meters in homes, sensors in substations, thermostats, all sorts of IoT devices. The third would be cloud. While AI is the brain of the grid and IoT act as the eyes and ears, the cloud is the backbone that really enables it all. Cloud computing is fundamental in making grid flexibility scalable, secure, and efficient. So really exciting times here. We're not just talking about some marginal wins here. We're talking about fundamentally changing how we work. AI is transforming every aspect of the energy industry, from predictive maintenance, load forecasting, customer service, cybersecurity. It's really redefining how we operate, how we make decisions, and ultimately how we serve utility customers. Looking at how we're able to predict grid failures using AI or optimize load balancing, managing demand response, and even forecasting energy prices. This is an example of so many examples of how AI can drive operational excellence and really elevate our decision-making capabilities to new heights. While technology has delivered very impressive productivity gains over the decades, the true potential of what AI is only starting to unfold is something to pay really close attention to. To me, the answer is simple. It's simply accelerating it. We're no longer talking about small incremental steps towards the energy transition. We're at the forefront of a transformation that is reshaping the very foundation of how we produce, distribute, and consume energy. AI real-time grid management at scale and at speed that human operators could never achieve. The biggest risk here isn't AI. The biggest risk is, in my opinion, inaction. The question is no longer if AI can enable the energy transition. It really comes down to how fast we can harness its potential and begin delivering those new value propositions that didn't exist before.